This video is about binomial probability distributions. Binomial probability distribution is a special kind of probability distribution. Bi here means two, right? So this kind of distribution only have two possible outcomes. One is success, one is failure. This is one of the important properties of binomial probability distributions with only two possible outcomes. There are several other requirements. The second one would be you can only have a fixed number of trials. Usually we use n to represent this fixed number of trials, or we can call it the sample size. Each individual trial must be independent. That's the third requirement. So that means any individual trial cannot affect the result of any other trials. And the fourth requirement is the probability of success of each trial must be the same. Usually we use P for the probability of success. And the probability of failure, we will use the letter Q. And you can tell P and Q, they will add up to 1. Right? So Q will be equal to 1 minus P, because there are only two possible results. One is success, one is failure. So either you success or either you succeed or you fail. So say the probability of success is equal to 0.01, and the probability of failure will be equal to 1 minus 0.01, which is 0.99. And there's a formula finding the probability of having X successes in n trials. So finding X successes in n trials is P of X. Well, this is equal to, use this symbol. So this is the formula. Let's look at each factor here. So first of all, this is the combination of choosing X items out of n items, right? And P here is the probability. X is the number of success, where Q is the probability of failures, and N is the total number of trials, minus X is the number of successes. Okay, so this is the formula we use to find having X successes in n trials in a binomial probability. So let's look at one example. When an adult is randomly selected, there is a 0.85 probability that this person knows what Twitter is. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. This is clearly a binomial probability distribution, because either the person knows what Twitter is, that's considered success, or the person randomly picked does not know what Twitter is, that will be considered a failure, right? So here we know the probability of success, P here equals 0.85. And that's the same for every person, every trial, right? Every person we ask. Okay, now what is n in this case? Well, we're trying to find the probability of exactly 3 out of 5 randomly selected adults. So n here will be equal to 5, right? That's 5 trials. And X will be the number of success. Here's 3. Okay, so since we know P, we should know Q. Q here equals 1 minus P, which is 1 minus 0.85, which is 0.15 here. Okay, and what are we looking for? We want to know the probability of exactly 3 of 5 randomly selected adults knows what Twitter is. So basically, what is the probability of 3 adults, exactly 3 adults out of 5, random selected adults know what Twitter is? So P of 3 equals, according to the formula, that is the combination of, okay, so N here is 5. So the combination of choosing 3 items out of 5 times P. P here is 0.85 to the power of x. X is 3 times Q. Q is 0.15 to the power of n minus x. N is 5, x is 3. So 5 minus 3, which is 2. Okay, let's do the calculation here. First of all, what is this part? This part is, first you start with 5 because n is 5, right? 5 times 4 times 3. Let me stop here. Divided by 3 factorial, right? 3 times 2 times 1. So this is the combination of choosing 3 items out of 5. Okay, times 0.85 cubed times 0.15 squared. Using a calculator, we'll get 0.138178. That is the probability of having exactly 3 adults out of 5 knowing what Twitter is. Of course, you can also use StatCrunch to solve the same problem. So you will go to Stat, Calculators, and Binomial. Here for N, we have 5, right? And for P is 0.85. And we want to find the probability of X equals to 3. That will give you 0.138178, 13, and so on. So that's how you find binomial probability using StatCrunch. So now let's go back to this example. If I'm adding a question asking, find the probability of 3 or less adults know what Twitter is, how do we find that? Well, if you find the probability of 3 or less adults know, that will be P of X less than or equal to 3. Right? Basically, you're looking for P of 0, P of 1, P of 2, P of 3, adding up together. Since we already know what P of 3 is, here we will just have to find what is P of 0, what is P of 1, and what is P of 2. Right? So let's do it one by one. P of 0, by definition, that will be C, the combination of choosing 0 out of 5 times P of 0 times Q of 5 minus 0. So what is the combination of choosing 0 out of 5? Right? If you choose nothing out of 5, there's only one probability, one outcome. So that's equal to 1. 1 times P of 0. P here is 0.85 to the power of 0 times Q is 0.15 to the power of 5. So 1 times any non-zero number to the power of 0 is 1 times 0.15 to the power of 5. So 0.15 to the power of 5 is, okay, I will round it to 0.000076. That's P of 0. Now P of 1. That is equal to the combination of choosing 1 out of 5 times P here is 0.85, right, to the power of 1 times Q 0.15 to the power of 5 minus 1, 4. So do the calculation. This is 5 over basically 1. That's 5 times 0.85 times 0.15 to the power of 4. So this will give you, 0.0021516. For P of 2, that is equal to combination of choosing 2 out of 5 times 0.85 squared times 0.15 cubed. So here we have 5 times 4 divided by 2 times 1 times 0.85 squared times 0.15 cubed. And go through the calculation, we'll have, and I did the calculation on the calculator, I have 0.02438. Alright, so the probability of having 3 or less adults know what Twitter is will be equal to P of 0, 0.000076, plus P of 1, 0.002516, plus P of 2, 0.02438, plus P of 3, which is 0.138178. Adding them together, I will get, rounded to the nearest thousandth, it will be 0.165. Of course, you can always use StatCrunch to find the probability, the binomial probability value. You go to Stat, Calculators, Binomial, and N, in our case, is 5, P 0.85, and we want to know the probability of X less than or equal to 3, and here's the value, 0.16479. Next, I want to talk about the mean and standard deviation of a binomial probability distribution. So there's a formula. The mean of a binomial probability distribution is n times the p. P is the probability of success. Right, the standard deviation, sigma, is equal to square root of n times p times q, where n is the number of trials, or your sample size, p is the probability of success, and q is the probability of failure. Let's use the same example earlier, of the one about Twitter. We know n is equal to 5. Right, p is equal to 0.85 and q is 0.15. With these three values, we can find the mean of this binomial probability, which is mu equals 5, okay, n times p, so 5 times 0.85, which is 4.25, where the standard deviation sigma is equal to square root of n, 5, times p, 0.85, times q, 0.15. So go through the calculation, we'll have 0.7984 That's the standard deviation of this binomial probability distribution. Remember, we talked about range rule of thumb. So here's the mean. Any number that is greater than the mean plus 2 standard deviation, any number above that is considered significantly high. Whereas any number lower than 2 standard deviation of the mean, any number below that is considered significantly low. So in our case, mu 4.25 plus 2 standard deviation will be equal to, so in our case, any number that is greater than 5.85 is considered significantly high, and any number that is less than 2.65 is considered significantly low. So this means if you find 5.85 people out of 5 people believe in or know what Twitter is, that will be too high, which is, impossible to have this value because your sample size is 5. You can't get 5.85 out of 5. So basically no number is considered too high, right? Even though you have 5 out of 5 people know what Twitter is, it's not a high number. But if you look at the low value, any number below 2.65 is considered too low. So if you have 2 people out of 5 trials do not know what Twitter is, that will be considered too low. And any number in between 2.65 and 5.85 is considered neither significantly high nor significantly low. Those numbers are not significant. So if you count whole numbers, in this case, if you have 3 out of 5 or 4 out of 5 or 5 out of 5, those numbers are not significantly high or low.